Welcome back. Let's continue the big data concepts. Our next topic is HDFS architecture and commands. What is HDFS? HDFS is Hadoop distributed file system. It can be used to put and get files from the file system, which is as similar to the file system, but it is distributed across the nodes with the Hadoop environment. A Hadoop cluster can be decided based upon the number of nodes which are connected together, and each and every node is having the capability of the data capability and also the computing processing power. Each and every data node is connected with the Hadoop ecosystem and which can act like a data node. And in the Hadoop distributed file system, all the data nodes are connected together, and when we are uploading a file into the HDFS ecosystem means it is further splitting this particular file into the multiple chunks, and each and every chunk of data can be stored into the respective data node and it update back into the name node. And we can discuss all this particular entire architecture in the next slide. And the HDFS is basically used to store your data and get your data from the HDFS system. Differences between the laptop file system and distributed file system means in our laptop file system we can create or upload or update your files in a file format in the single node, but in distributed file system we are uploading our data and splitting the data into the multiple chunks, and each and every chunk can be stored across the distributed node, and we don't have a clue where exactly this particular chunk is getting stored. And the Hadoop infrastructure which internally manages all these particular chunks of data further split and then store it back into the Hadoop ecosystem. Hadoop distributed file system is having the capability like you can write once and read many times. And suppose for example if you are uploading your data means it can upload for the very first time, and if you want to re-upload your file, that means it will delete your existing file and then re-upload it. The architecture is designed like you can upload your file for the only one time. That means you are writing into the respective blob for the one time, and that can be leveraged with the many times read approach. The default block size of HDFS is set to 64 MB or 128 MB. That can be set with the configuration settings in the HDFS, and it is a low cost per byte because this particular HDFS component is leveraging the disk uses within the cluster, so it is like a low cost per byte. High bandwidth to support the MapReduce programming. The MapReduce programs which run on top of the Hadoop ecosystem, which can fetch the data from the HDFS, so that the HDFS layer which is providing the high bandwidth. The HDFS layer is designed with the write once and read many times, and it is providing us the throughput to read with the high bandwidth supported to the MapReduce programming. And it is providing the data reliability within the HDFS ecosystems. Here is a HDFS architecture, and which constitutes of the name node. Name node basically which act like a master node which basically collects all the information of the data nodes. Like in our Hadoop cluster we do have the n number of data nodes are separated together, and which is connected via the bridge of network of Hadoop environment. And this particular name node, whenever the client puts some data into this particular HDFS, like a upload activity means the name node can elect the random data nodes, and then it will copy the data into the respective data nodes. That's where we can see like the name node can manages the metadata operations, and even it can split this particular data into the different blocks, and then it can pass on to the respective data nodes. And name node is responsible for managing the metadata management of the data, and the each and every chunk of data can be uploaded back into the data node, and each and every client can submit the request to the name node, and name node can is responsible to upload multiple chunks of data into the data nodes. Here we can see like this particular rack 1 set of data nodes would be there, and here we can see like okay, each and every data node which is having the different sized chunks, and each and every chunk of data can be stored back into this particular data node, and this particular offset information is managed in the name node. Whenever we made a request to read the data, then name node can serve this, and then it can read the particular offset information from the data nodes back, and then it will combine this particular data elements, and then it will provide you the output. So that is how actually the HDFS architecture would work. And here you can see like this is the distributed computing, and here we can see like the each and every data node is capable of storing the information, and name node which combines the entire architecture of the data nodes to provide like a distributed manner. Here are the few HDFS commands which can be useful for you, and you can able to see the version of the HDFS using this particular command, HDFS DFS version. And if you want to list down the files which are available in the HDFS, then you can list down with the -ls command. And if you want to create a new directory, then you can use this particular -mk directory, and you can provide the directory name so that you can able to create a new directory in the HDFS. And if you want to upload a new file into the HDFS, then you can provide the local file path and the directory path to upload into the HDFS directory. And if you want to copy from your local machine, then you can use this particular copy from local command so that you can upload your data from local source path into the destination HDFS path. And you can upload your files with this particular two options which are readily available with the HDFS. One is with the put command, and another with the copy from local command. And you can get the respective file which is available under the respective source path, right? Source HDFS path. You can get this particular data information from the HDFS. And parallelly you can copy to your local machine, and you can provide your source HDFS path and then destination local path via this particular command. And you can list down your file, and then if you want to read the respective content which is available under that particular path, right, then you can use the cat command to list down the entire file so that it will display the contents on the screen. If you want to move your file from source to destination, then we can use the -mv command to move the file from the source path to destination. If you want to copy a file from one particular HDFS location to another location, then we can use the -cp command. And if you want to see the stats about disk uses, like how much volume of the data which is occupies in the HDFS, then here are the important command for listing down the entire history of the disk uses. If you want to delete a file, then we can use a command like -rm. These are the few important HDFS commands which can be useful in our day-to-day life. We can see it in a interactive lab session in the next video. Thank you everyone.